Please come to the front. We will start with the demo session and the presentation. Hi everyone, welcome to iBeam. I'm Laura. I'm the program manager here and work very close with the residents as well. You can see to scale here, it's our current show with the projects of our current project residents. And we dedicated this one event today to Brandon, yeah, absolutely, it's his event. We also want to introduce our residents to work on their own public program to get the discourse running and present a platform where they can talk about their projects and their practice. This is our open hardware project, and Brendan is working on it for a while. And I will let him introduce himself and the project in a second. I just want to say thank you for everyone for being here. I also wanted to thank Billy, our creative tech manager, who's here too, Erica, director of community engagement, and especially our interns, actually. It's Judy, who helped me with assisting with the residents, with the show. It's Dun Lee, our new creative management, creative technology intern. It's Yu Meng, who was particularly working with Nancy Denise on a project in the BioFab lab there. And Marcia, newly on board as well. We're so glad that we have those people, because without them, we would probably not exist. So thank you so much for being here. And this is Brandon talking about his project.
Thank you. I got a little mic. Wow. So it's an incredible experience to be here today, because 10 years ago, I was 19, an undergrad at SUNY Purchase, and one of my professors recommended that I check out a show at iBeam. And that's when it was on the west side in Chelsea. And I went there and my mind just completely exploded. I thought it was the coolest thing I've ever seen in my life. And it had never crossed my mind to even think that I could get a residency here or be an electronics artist or a media artist. And so it kind of happened. And all of you beautiful, beautiful people came out tonight to hear me talk about my project. And I really just can't believe that I'm here. So thank you so much. Okay. And so this is also kind of my first solo thing. I've done lots of shows, but with other people, so I'm nervous. I'm kind of nervous. Thanks for your patience. And before I get going, I just want to thank a few people. So first of all, I want to thank my professors at Parsons who are integral in helping me come to the realization of this project, and they're John Sharp, Ed Keller, and Ted Byfield. Sorry, they're not here tonight. Where were they? I don't know. And then I've had a lot of electronics mentors in my life, whether they know it or not. They've really touched me and taught me a lot of skills that I don't think I would have been able to pick up on my own or inspired me. And those are Zach Murphy of the Public Theater, the team at Breakfast, Stephen Litt, and Philip Stearns. Philip Stearns especially, because the system that I'm discussing tonight is very similar to his, except it runs about 100 times slower and connects to a computer rather than a speaker. If you're interested in any of Phil's work, I'd really recommend it. Interested in anything of this, you should check out Phil's work. I also want to thank Brian Ma, who started this project with me, but at one point we kind of chose different paths, and his work is on display in a completely different form in the gallery back there. It's kind of these black and white random experiments. I hope you get a chance to look at that. I'd like to thank everyone at iBeam, obviously, because you're making my dreams come true. Thanks guys. And then finally, Karina, my wife. We got married last week. For letting me totally destroy our apartment when it comes to these projects. I take over the whole place. There are just these little metal things that get stuck in your foot really easily, so thanks for dealing with me. And so I want to start the presentation tonight with an image that's enchanted me pretty much my whole life. I think when I was in middle school, I saw Aliens. My father and brother just we watched it hundreds of times, not even exaggerating. And when I was a kid, there was this scene where they're discussing one of the maps, like to set up their kind of like fortifications to protect themselves from the aliens. And when I was a kid, this thing flashed across the screen, and I thought, oh wow, that's really crazy. I can't believe the future is going to be that complicated. And then I saw it last month again, now that I'm like more critical adult. And I looked at the map and I'm like, oh my God, that doesn't make any sense at all. Like, this is a future where like these people who you're supposed to be relating to and like kind of feeling what they're going through, and you realize that they're kind of inhabiting this alien world. And I love this scene so much because it kind of taps into like, not the technical details of aliens, but kind of the mood. This kind of like alienation from your own environment, or having like these creatures invade it and use it against you, and you have to kind of construct things to keep them out. Or like some scenes, the aliens will use the elevators to attack the humans. It's baffling. So I'm looking at this, and then I'm looking at this, which is the circuit layout of something I've made, and I'm like, oh my God, it's totally weird. Like, it doesn't make any sense to me. And so tonight, as I discuss my project with you, I want to kind of do the same thing that aliens did, kind of give you the mood or like the sense of the thing, rather than the technical details, because the technical details are like kind of overwhelming, and it's just, I mean, I'd love to go into them, and I plan to document them and make them open to the public, but right now, you know, let's stick to the weird stuff, like the feelings about the instrument. So I forgot to mention in the first slide, the project was originally called Theseus, but within the last week I decided to rename it Destiny Clock, mostly because the project kind of was based upon another one and changed over the course of my residency to become something completely different. So I'm calling it Destiny Clock now. So if I say Destiny Clock, I'm talking about this image, this instrument. Instrument's also a weird word. We'll get there. So let me just tell you a few things about it. It's not a synthesizer. It's based on some kind of principles that are involved in synthesizer design, but it doesn't like make any sound. It kind of functions the same way like a keyboard does. It only sends packets of information to a computer. It needs a computer to function. It connects over USB. And these packets get sent along to the computer. Computer interprets it and puts sound out. So that's why people think it's a synthesizer, but it's not. It's kind of like a programmable interface. And you kind of connect these separate modules to one another using these patch cables. And through those patch cables, you get interesting patterns, and those patterns are transformed into music. So one of the analogies I kind of like to make is the player piano, like, because it's very easy to visualize. There's the player piano. Inside the player piano is a piano roll, a piece of paper that's wound up, and where's my mouse? It has these punched holes in it. As these punched holes are moved through it, there's a mechanism inside the piano that kind of like reads those and plays the keys automatically. And so I call this the hypothetical past, because imagine that there were a machine that you could program to automatically punch holes in a piece of paper, and that piece of paper was then fed into the player piano. And that's pretty much what's going on here. I've made this instrument that kind of like generates a score in real time that gets sent along over this protocol called MIDI, which stands for Musical Instrument Digital Interface. It's been around for 30 years. It's a really widely used protocol. And then that goes to the computer, and the computer cranks out some good sounds. The other important thing about the instrument is that unlike synthesizers, it only has like a 1-bit resolution. And when you look at it, you'll either see LEDs are on or off. It's not this kind of like smooth waveform. Like the signals it's producing are like either boom or not boom, 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 boom. And so this kind of system necessitates a lot of programmatic skills. In fact, all of the modules are based in some way on like computers, like the fundamentals of computer science. And just to like lay some heavy tech talk on you really quick, there's like shift registers, multiplexers, clock dividers. These kinds of things take an information input that's either a 1 or a 0, and then put out something completely different. in the form of another 1 or 0. You take those outputs and plug them in to the final master input controller, which is shaped in the form of a keyboard, and that kind of gives you the music that's coming out. So the next thing is that the system runs on like a fundamental frequency. So you're having like a clock signal that's like, you take that, and using a patch cable, you plug it into something else, and it will change that frequency slightly. So it could go, or, and then it gets more complicated from there. But the main idea is that because you have this one fundamental frequency that's being subdivided and kind of cut up into different pieces, there's like this architecture or resonance that kind of suffuses the music you're listening to. It always kind of makes sense, but you're not sure why, but there's some kind of familiarity with all the ways the notes are relating to one another. So I really liked these examples from Alexander Calder, where he created these mobiles, and they're all based, it's kind of hard to understand because they're like interpretive, but this piece up here is the fundamental frequency. And all of these other pieces that are descending from it are mathematically relational to this one. Like this could be 4/5 the size, and because it's 4/5, the next one has to be like 2/7 or something. And that's what kind of like makes it feel so special and important, while still kind of coming off as like organic and natural or not mathematical. But it is, that structure underlies it, and that's kind of like a visual equivalent of the sound you experience when listening to it. Okay, one last technical thing. This system is like super simple. It takes one simple concept that anyone could pick up on their first day of learning Arduino. I feel like a lot of people know what Arduino is in this room. It's kind of like an electronics programming environment for hobbyists and beginners. If you take the one sketch that blinks an LED and the other sketch that reads whether you're pressing a push button or not, and take those two together, that's what this whole thing is, except just built upon endlessly. So that's it. I mean, you could make one of these things yourself in like a few hours, and then if you had enough time, you could do it in like a year or two, like I did. Make it like really crazy. So what is it like to use? Because this is kind of based on like a traditional analog synthesizer format, it's different than what you might expect. So it takes a lot of patch cables. That's kind of a new thing. It becomes like a bit tedious and a bit difficult. And at some point you might find yourself where there are too many patch cables and you're like, I have to get to that one spot, but I can't because there's a forest of wires standing between me and where I want to go. And those are all things that I'm really fascinated and intrigued by in the results that I've kind of come up with. I've always been interested in constraint and working within a kind of difficult environment. I also wanted to create something that wasn't restrictive. Like, I feel like anyone could pick it up, and the only thing that would help, like, so for instance, you can't just pick up a violin and play it. It's like difficult. It takes years of practice and familiarizing yourself with it. Whereas on the hand, like the Destiny clock hand, you can pick it up and you can start using it, and there'll be nothing to kind of like limit you from doing whatever you want besides your own level of patience and engagement with it. And that's always intrigued me, so that there's not like kind of any barrier between you and wanting to create things. The other thing is that it's really small, like smaller than anything else I can think of in the electronic musical instrument world. It's incredibly dense. And so this is an example of like a kind of old school synthesizer. And if anyone's familiar with these things, we know that people can like fill entire rooms with these things, these patch cables running all over the place. And so this experience of having kind of like a fort isn't the same. Like, it's incredibly portable. The patch cables themselves are like basically free. You just buy a bunch of wire. I mean, they're probably is like half a penny a piece, so you never run out of patch cables. And these are probably like 4 or $5 a piece. So it's interesting that it's portable, it's relatively cheap, the limitations are lifted. Okay, and I wanted to include this slide here because what you're going to see tonight is like an exposed circuit board version of what I've made. I didn't create any kind of like nice box to put it in. I can make nice boxes, but I kind of decided not to. So this is kind of like what it could have been. And at one point I decided that not having labels was an interesting route because similar to like, as I mentioned with the violin, without any kind of labeling, the instrument kind of demands and expects a familiarity from the user. And I think that kind of creates an intimacy between the person who uses it and the instrument itself. You don't need some kind of thing telling you what to do constantly. You're fully aware of what's happening. So maybe not the best decision this early in prototyping, like because no one in this room, except maybe Pam, who's messed with it a little bit, knows how to use this thing, but that's kind of what I was going for. And maybe the nice case will come later with the next version. So I just want to talk about some design parts of it. So it's a modular project, and modular design is kind of like a bigger field than I think a lot of us expect it to be. There's they take different forms of permanence. So I love this example in the top left of the modular home because it's kind of like composed of these building blocks that a designer puts together, and then they all kind of like are built, and then it's permanent. And usually when we think of modular design, we like to think of Lego because it's fun and you take things apart and it's playful, or maybe a bit more depressing, like office furniture is modular. Like, yeah, you can move it around and rearrange it, but you're never going to, even though that's been built into it. Modular design is great because you can match your price point. I'm very interested in affordability when it comes to this project, as you might have noticed, and maybe I've like discarded those a little bit for like artistic ideals at this point. But modular design allows you to kind of like, oh, you've got $50, well, you can buy one part, have fun with it. Oh, you've got $500, buy 10 parts, have fun with it. And you can kind of like find your entry point based on your financial ability. But electronics are fascinating because they're modular in what I like to think of as like a horizontal and also vertical way. So up here in the top left, we've got these basic building blocks of like electronic circuits. They're capacitors and resistors, and by putting these things together, you can create oscillators or any kind of like electronic circuit. But once you combine them together, you get an integrated circuit. So inside this little black chip are kind of microscopic, kind of compact version of circuits that have been composed using these elements. And in the project I have here, Destiny Clock is composed primarily of these integrated circuits, which are doing the fundamental footwork of your CPU. So over here, we've got like a CPU. Every personal computer and like mobile phone has one. And this is composed entirely of integrated circuits all speaking with each other. But then jumping between the physical and kind of like the abstract, the way the CPU is kind of programmed is using a language that's also modular. So you can kind of create functions and objects and compartmentalize the way you're programming this thing that's modular and compartmentalized. So I just find it fascinating that it scales up in this way. And it becomes apparent in like most consumer products that modularity is like what you do when you make something electronic. Over on the left, there's a motherboard for a personal computer, and it's not modular in the sense that Lego is, but it's modular in that, oh, you want a new video card? Take out your old one, put in a new one. Like a bunch of industrialists have decided on this standard in order to like facilitate swapping in and out of these parts in case of failure or in case of like upgrading, because things are changing so quickly. It's important to have modular built in. Little Bits is like a good example of kind of like fun, playful stuff. And then Project Aura, I don't even know if that's still happening, but it's like a modular cell phone project. So I loved all these ideas, and I decided to kind of put them to work for me in my graduate thesis at Parsons. This is Theseus. This is like the project that I came in here with before it kind of changed shape. And I loved that I could kind of create these individual creatures in this environment and have them communicate with one another in a strange, unexpected way. And so when I went modular, I decided to like get as weird as I could. Over here on the left, this is a module that represents world population growth based on like some statistics. So like every 3 seconds, you know, maybe the light in North America would light up and it would be like, oh, a child was just born. And if you want to check this out, it's over there at one of the computers. And those lights blink as children are born, based on information from 2012. The middle one's a little complicated, but it's definitely weird. Just take my word for it. And the right one is based on sampled blinks from an RPG video game I was playing during my thesis. So it kind of just like bled into my mind. But these characters would stand in a field and like have these dialogue bubbles appear above them, and intermittently they would blink. And I was like, oh, that's kind of cool. I bet that would make like a neat sound if you sampled it. So I used some software to capture their blinking, and then took all that information, put it onto like a little chip. So when the LED lights up, that kind of represents when a character did actually blink when I was playing this game. And then you can take that blinking, patch it out, plug it into like a key, and plays that key. Then you've got music coming from your video game. Anyone? Yes. Yeah. So there's weird, like, modular allows for weird, creepy stuff like this. It's completely impractical, useless, but can be very, very funny and kind of reminds you that this isn't like a completely serious thing. But maybe I decided I didn't like modular at some point, or at least all the way, because you get these massive systems of modules that were designed by individual designers that, you know, they only had like a thought that it was going to be used by someone else or integrated into someone else's system or in this context. And that can be thrilling for a lot of people. But at one point I realized, you know, like maybe I just kind of want to do something contained. I want to like put my mark on a system and have like, when someone uses it, I want them to be like, oh yeah, Destiny Clock is great. Like that's a weird thing made by one person, and it's like a whole system. The other thing with these modular systems, and I was mentioning about the affordability of them, they can be like addictive in some senses. There's a like slang term that goes around the Eurorack community, which is what this format is called. It's really popular right now. It's called Eurocrack, because I mean, it's funny, but people spend like $10,000 to $20,000 on systems like this, and they're like, oh, if I just get like this really great new VCO, like it's really gonna like change my life, and it just isn't. So I didn't know if I wanted to like go into this world and kind of get mixed up with all these other kooky characters. So semi-modular design became really appealing to me. These are just some examples of past and present systems that have been released that are technically semi-modular. And when I say semi-modular, I mean that it's like a closed system that kind of only understands itself. You can't connect it to anything else. I mean, in some cases you can, but you might need some special thing in between. But you're restricted, constrained to the few things that you have available to you. And I was like, oh, that's awesome. It makes you feel like you really made something, and each decision was like very precise. And all the modules are meant to speak to one another, and I really like that. Okay, so this is more the feely stuff now, rather than the technical. And I wanted to start by sharing with you a project I did while in grad school. Basically, you've got these kind of points generating from the center that move out, and when they reach a perimeter, and kind of semi-arbitrarily, when they cross the perimeter line, play a note on the piano. You can modulate the frequency that the note this is an instrument. Like, I'm an instrument designer. Like, you've got all these kind of things down here that you interact with, and like the complexity is like, it's there. Like, you have an infinite number of combinations. That's what an instrument is. Like, I did it. And so at the time, Elliot Sharp, this gentleman on the right, who's part of the New York City avant-garde music scene for like the past 30 or 40 years, he was, what do you call it, a fellow at one of the organizations at Parsons, and I was like, I'm gonna reach out to Elliot Sharp because he's like an instrumentalist. He's not even like a composer or a musician. His job is to like play musical instruments and interpret them. So I was like, I'm gonna show him my instrument, and he's gonna tell me it's great. And I just wanna show you a little of Elliot's music, because to form a pretty strong contrast. So a lot of people were like, oh, that's just noise. And you couldn't be more wrong. I mean, what you're seeing before you is like the entire history of guitar playing condensed into like a new philosophy interpretation of like this instrument. And it's really incredible. It kind of feels like that wormhole scene in 2001 to listen to this guy play music. So I sit down with him, I show him the instrument, and he goes, that's not an instrument. I was like, oh damn. It's like, it's an installation. And I was like, oh no, I'm not, no. But he's just like incredibly right. And what he kind of thought of as an instrument was this medium, like something that allows you to connect with other people in the audience. For him, music is all about performing and presenting your work to other people. Essentially, like, music doesn't exist unless you share it with someone else. You play, like, if the tree falls in the forest, does it make a sound? His answer is no, it doesn't. And so you use your instrument as a way of like conveying things and taking in the energy from the audience and being able to kind of shape it and have a conversation with them. Also, part of like instrument design is kind of forming a critical history of the instrument, developing and pushing and kind of interpreting and reinterpreting. And I was like, oh, it's critical, like someone can go into my source code and change it a little bit. And he's like, no, it's not really ever gonna happen. And I was like, oh. And I just thought, I was so struck by that because now I'm like, I'm definitely not a musical instrument designer, even though I make these musical things. So I was kind of trying to like figure out what's going on here. And what I came up with is that I'm a musical environment designer. And I'm drawing like a lot of inspiration from terrariums, these kind of like enclosed spaces that have these miniature, and even there's like a scale variable in my project where I like it small and portable. And this is like really striking to me. It's something I've kind of come across in the past few weeks of thinking of my work as kind of miniature. And if you listen to the pieces that I've got set up tonight, I think you'll be able to get a sense of that. It's strange. And so if any of you RSVP'd earlier, you might have noticed that Benton Bainbridge and Joshua Kopstein, Zen Albatross, were going to perform tonight. And I had these instruments ready to go for them. And I was like working with them, and then I suddenly realized like, you cannot perform with this. It's like more of something you put down and then you kind of approach and you listen to it, and then when you get bored, you just walk away. It's not something you kind of like force people to listen to. It doesn't have the ability to create a conversation with an audience. And so regrettably, I asked them if they would mind, taking a rain check, and we would perform some other time once we figured out the instrument a little more. But right now, terrariums and aquariums are just really striking to me. The other thing about these instruments is that I think it's important that a new kind of genre of music is coming out that's demanding that it's not. Thinking is like integral in understanding what the music you're listening to, because you're not just listening to the sound and seeing the sound being made, you're also seeing all of the options that aren't being used. If you look at kind of the top half of the instrument, wherever it's set up, you only see like a few cables being used, and like there'll be like a seizure-inducing blink storm, but only a few are getting used. And I love, being bathed in this spectacle. And it also reminds me of this room from Alien. This is the ship's AI called Mother. I also find it to be like kind of womb-like, where you go in and you're comforted by this sphere of blinking lights. I was going for that. One of these blinking lights to make you feel good. So, what's next? There are a couple things I want to mention. So the first is that I haven't found my perfect user. I'm still searching for them. I think this instrument, whatever, working on what I want to call it or define it as, but I'm still seeking someone who really wants to sink their teeth into it, get to understand it, share things with me. I've met a few people who've like really blown my mind. They're like, oh, what if you plug the shift register into the multiplexer? And I'm like, whoa, that's beautiful. And I'm looking for more people like that. I guess it's important to note very quickly that just because it's digital, it can like put out any kind of information. It can do text, it can do video game kind of joystick inputs, it can do MIDI, which is what I'm interested in most for musical composition. And it can also, well, because it works on MIDI, it can also integrate with like a lot of VJ or visualist software. Or if you're like a good programmer, like open frameworks could be talking to it pretty easily. So what else is next? Should I mass produce it? You know, electronics are favored by mass production, and I'm running into a lot of problems there. And I don't think I'll be able to mass produce it, actually. So there might be some kind of version where it's a kit, and I make half of it, and then you assemble the other half yourself. But the thing that I'm really, really loving right now is this idea of a potential external residency program. I would create, you know, a few of these things, and then every 6 months or so, people would apply to use it, and I would get a sense of how well they would vibe with it. I would ship it out into the mail to them, and there would be an expectation that they would produce work on it, and they would produce video or have it show in a gallery or, you know, do some compositions or integrate it into their other instruments. And then when they're done, they send it back to me, and then I send it to someone else. That kind of retains its kind of like special, unique, cute, like microscopic nature. So yeah, that's what I'm thinking about doing. Tonight, though, I've got 4 things on display, and I still have one to set up, and it's going to be the real crowd pleaser. So the top left is Panoramical, and Panoramical was designed by Fernando Ramallo, and the composer is David Kanaga. It's an awesome experience, and I happen to be the controller designer for the game, and I brought the controller tonight mostly for fun. It's not really related to my I-beam work, but it does represent that like I can make pretty things. So when you see this ugly exposed circuit board, be like, oh, he did that on purpose. So I actually have to use this computer, so I'm going to set that up after the talk. And then top right is Theseus. That's the big white box. That was my graduate thesis. That runs on some slightly different principles, and it's a failure, ultimately. I mean, it's not failure, dead end. I'm happy I have it, happy I made it, and I dig it. And the bottom left is the Destiny clock. I've got 2 of those set up. One is synced to Patatap, which is a website. Jono Brando, he designed this kind of really fun website where if you just press like any letter on your keyboard, it creates this kind of like image and sound. And because Destiny clock can do keyboard output, I have it set so that when you plug a patch cable into one of the inputs, it plays a key and then it plays the Patatap sound. And that's it. Yeah. Thank you. All right, ready for questions? Let's go.
Can you talk a little bit about what's receiving the MIDI from your unit?
Well, It's interesting because I'm not much of a composer anymore these days. I've really found myself leaning towards the design and construction of instruments, in quotes. So it's just Ableton. There's nothing fancy going on. It's just one of the default kind of sounds they have available.
Like one of their inbuilt synths? Or
Yeah,
something?
like a VST. So just a VST synthesizer.
So it's looking to receive certain signals that trigger certain parts of that synth?
Mm-hmm. Just the notes. It's not controlling any of the...
So it's note on?
Note on, note off, that's it. And if you were like totally into this thing, you could like make your max patch so that like, oh, I got a note on signal, like change this MIDI CC value. Apologies, everyone. And then you could do things like that and have that control the synthesizer. Yep.
I have another question.
Oh, okay.
Yeah, in your discourse on your opinionated discourse on the modular world, you left out the things like reactor, max, that there is this whole sort of purely digital modular world that doesn't get you into the addiction and all the rest of it. Well, I mean, it maybe its own kind of addiction, but it's, it is purely digital.
Yep.
And it is compact and it's light and all
Right. Yeah, and I really like those things. I guess
did that inform what you were doing with?
Yeah, it did, because I'm not analog purist. I've heard these like synthesizer sounds. I'm like, wow, I really like those, and it became at one point I realized the only way I could get those sounds was by like the sound and the experience of creating the sound are kind of separated now. Like the Reactor software supplies the sounds of a modular synthesizer, but doesn't give you the same experience of patching to create the sound. And I think that's important. And to limit it to just a few people who have like several thousands of dollars, I don't think is exactly, fair, especially when it could be done so cheaply. And so I set out to make it more accessible and like give people this traditional approach to making music through patch cables, because I think there's only certain kinds of music that can be made using patch cables. Yep.
I like the discussion about the terrarium and the guitarist telling you about the instrument, or that it wasn't, whatever. But I'm curious about because one of you said that there's like this minimal barrier really for starting to make sounds with it, because there's no background knowledge that's necessary.
Well, there's no dexterity required. There's no muscle kind of training involved.
With playing an instrument like guitar or piano or something like that, there's an element of feedback that you get from the instrument that you then play with, you hear what it makes and you play with that and you hear what it makes again. Are you able to do that here, depending on how you generate the notes, how you interact with control surfaces?
There are possibilities. I don't think any of them are exactly good. So, for instance, you could put a little motor on it, so when an input was received, it would like vibrate a little bit, and that could count as like haptic feedback or something. But I think what you described, like the relationship and physical experience of an instrument, not just sonically, but physically, tactically, like when you strum it, like the body resonates and you absorb it in your body. It's an incredible experience. And so I don't know, I can't think of a good way to replicate that with what I'm making here. I think there are like cheap ways that kind of like are attempts at it, but can't capture the same thing.
Right.
Yes?
I have two questions.
Okay.
One is, how did you make your clock? How did you make your clock?
It's just an app mega chip with like a delay, blink without delay sketch. I don't know. So it's just, it's a programmable Arduino.
It's just the Arduino's clock.
Yep.
And as the designer of the instrument, how do you see someone mastering? How would you like detect that some musician has mastered your instrument?
I'm not sure. I'll think about it. Thank you.
That's what your residency is for.
Question in the back?
Yes? I could. Yeah. I think when people really throw around the word open source, and I've done some open source projects, and the amount of documentation required so that people don't send you emails relentlessly throughout the day is, it's overwhelming. Like, I remember spending 2 or 3 weeks of my life doing nothing but taking photos and writing text to describe things so that people wouldn't email me, and it gets huge, it's monumental. So am I not open, it's open source because like a lot of the modules themselves are just like, it's a multiplexer, it's a shift register, you just plug it in and it does its job. And so like you can't like close source that because it's just doing its thing. It's just being used in this weird way. So I'm not closed sourcing it, but I'm not like doing the intense documentation that an open source project demands because it's like frankly exhausting. But as the project becomes more popular, like even in the talk itself, I mentioned like how you do this. You just get 2 Arduinos, one's blinking, one's reading a push button sketch. And then that's all you need to do what you want to do. And so maybe I'll make the circuit boards available, but right now I'm really terrified of getting hit with like lots of emails.
Or even just some of the design ideas behind some.
Yes, yeah.
You one feature.
Yeah, sure.
You'll put your email.
Yeah.
Just like Luminous.
Yeah, I'd like to. Yeah, I'm not trying to be mean, just trying to, I want it to be done, and then I really want to like let everything go. Mm-hmm. Yes?
So sounds like using Arduinos for this is like an incredible workout, right?
Oh yeah, definitely, yeah. Well, that's, if you're making an open source project, you should use the tools that the community is most familiar with. And like, I'm a self-taught electronics kind of programmer person. And so like using an Atmega 328p is just like really easy because using anything else can be horribly painful to learn how to do. And that's, yeah, you're exactly right. So I think, let's just, one more question. Yes?
What are some, what if any teaching applications have you thought of using this for, and have you any stories or anecdotes about that?
I mean, teaching application could be potentially awesome, especially for elementary or middle school or high school, because part of the system involves digital logic gates, and they're visually represented with like blinking LEDs. And so teaching a student the fundamentals of digital circuit design through a system like this over the course of like 2 or 3 weeks or 2 or 3 sessions could really help them understand what's going on inside of these chips. So yeah, it's a big potential. I'm not much of an educator, so yeah, that's like more reason to open source it, you know, because like someone who is into those things could adopt these. Right? Before everyone claps, I just want to say, I'm going to turn on all the installations. Feel free to like touch anything you want. You really can't break it. I'm pretty sure you can't break it. I'll come over and maybe give you some tips on like what you can do to like change the tempo or change the volume or things like that. And so yeah, I hope you go over there and do some patching. And that's all. Thank you.